This is RamiBot, an AI cybersecurity assistant designed to automate real security workflows using specialized tools and evidence-based analysis. In this demonstration, RamiBot is running with a local AI model, not a cloud service. The language model is running locally using LM Studio, and the model used in this demo is Qwen 3.5 with 4 billion parameters. Running the model locally allows RamiBot to perform analysis without sending data to external services, which is especially useful for security and privacy-sensitive environments. In this video, we will run a blue team workflow against an authorized internal host and show how RamiBot combines AI reasoning with real cybersecurity tools. For this test, the blue team mode is selected. Blue team mode focuses on defensive analysis instead of exploiting vulnerabilities. The goal is to identify exposed services, understand the potential attack surface, and provide remediation guidance. The target used in this demonstration is an authorized internal host on a local network. The first step is reconnaissance. RamiBot performs an initial port scan against a target host, scanning ports 1 through 500. This scan allows the system to identify open ports and detect which services are exposed. Understanding exposed services is essential for defenders because every open service represents a potential entry point into the system. The scan results show that 2 services are accessible on the host. Port 22 is running SSH, specifically OpenSSH version 7.9. Port 80 is running a web server, Apache HTTPD version 2.438. These services define the external attack surface of the system. From a defensive perspective, identifying outdated software is important because older versions may contain known vulnerabilities. After identifying the exposed services, RamiBot performs a vulnerability intelligence lookup. Using the CVE lookup tool, the system queries vulnerability databases to identify known issues related to the detected software versions. This step allows RamiBot to correlate the discovered services with publicly documented security vulnerabilities. Each vulnerability entry includes a CVE identifier severity information and a CVSS score. CVSS scores help security teams understand the potential impact of vulnerabilities and prioritize remediation efforts. By combining service detection with vulnerability intelligence, RamiBot moves beyond simple scanning and provides contextual security analysis. Once the vulnerabilities are identified, RamiBot automatically generates a structured security report. The report is evidence-based. This means that every finding is derived from confirmed tool output rather than assumptions. This approach helps reduce hallucinations and ensures that the analysis remains grounded in verifiable data. The report begins with a summary table showing all confirmed findings. Each entry includes the affected service, the related CVE identifier, the severity level, and the CVSS score. This overview allows analysts to quickly understand which vulnerabilities represent the highest risk. After the summary, the report provides detailed explanations for each finding. For example, the report describes how a vulnerability could impact the system, what conditions are required for exploitation, and why the issue is relevant from a defensive perspective. This type of structured reporting helps security teams move quickly from discovery to remediation. The report also includes a simplified attack path, sometimes referred to as a kill chain. This section illustrates how an attacker might move through different stages of an attack. The process begins with network reconnaissance, where exposed services are discovered. From there, an attacker could attempt initial access, potentially targeting vulnerabilities in exposed services. If successful, the attacker might attempt privilege escalation in order to gain higher levels of access on the system. After that, persistence mechanisms could be installed, allowing the attacker to maintain access over time. Finally, the attacker could attempt data exfiltration, accessing sensitive information from the system. Understanding this attack path helps defenders prioritize which issues should be addressed first. The report also includes prioritized remediation recommendations. These recommendations are divided into 3 levels: immediate actions, short-term improvements, and long-term defensive strategies. Immediate actions may include enabling encrypted communication, restricting access to sensitive services, and applying security patches. Short-term improvements may involve upgrading outdated software and reviewing third-party components. Long-term recommendations often focus on strengthening the overall security posture through measures such as network segmentation, intrusion detection systems, and regular vulnerability scanning. By combining vulnerability intelligence with remediation guidance, RamiBot helps security teams move from detection to action. Once the report is generated, it can be exported as a professional PDF document. This makes it easy to share findings with security teams, management, or external stakeholders. The PDF includes the findings summary, detailed vulnerability explanations, remediation recommendations, and the raw evidence collected from the tools used during analysis. Having a structured report like this allows organizations to document security assessments and track remediation efforts over time. Finally, we can look at the skills configuration used by RamiBot. RamiBot operates through a skill pipeline architecture. Each skill represents a specialized capability such as port scanning, vulnerability lookup, or report generation. When a task is requested, the AI selects the appropriate skills and executes the corresponding tools. This architecture allows RamiBot to combine the reasoning abilities of large language models with real cybersecurity tooling. Instead of relying only on text generation, the AI can interact with the system, collect evidence, and produce structured results. This demonstration shows how RamiBot can automate a defensive cybersecurity workflow. Starting from basic reconnaissance, the system identifies exposed services, correlates them with vulnerability intelligence, generates a structured report, and exports the results in a professional format. By combining AI with real security tools, RamiBot aims to assist analysts in performing faster and more consistent security assessments. RamiBot is an open-source project focused on evidence-based AI cybersecurity workflows.